We are in Module 7, and now we're on Set B. So in this module, we'll be working on absolute value. And what we saw is how to solve an absolute value equation. And we know it's an absolute value equation because of the bars. And we also know the definition of absolute value is the distance from 0. And if you move a distance from 0, you can either move to the left or to the right. And that's why every absolute value equation makes two equations to solve. Well, we're going to use that same concept today. Only instead of doing an equation, we're going to do absolute value inequalities. So let's go to our notes. Okay, if I look here, solving an absolute value inequality is just like solving an absolute value equation. You're going to isolate that absolute value symbol. You're going to rewrite it into not one, but two. But today we're going to be writing not one inequality, we're going to be writing two inequalities. And that takes us back to Module 6, which is if you have two inequalities, it's called compound, and that means it needs to be connected by a word and or, which means we got to look for either an intersection or union, which means then we either got to know how to write the answer in set, builder, or interval. So what we're pretty much doing is taking everything from Module 6 and Module 7 and putting it together in one example. All right. So what's going to happen is once we get our absolute value isolated, before we break it up into two inequalities, we're going to have to know what the connecting word is because we're not going to see the word at the beginning. We're going to have to make the decision whether you use the word and or. And all you got to do is memorize. If your absolute value inequality has the greater than symbol, it's an or. So whether it's greater than or equal, you're using the word or, which means in the end you're looking to unite everything you've shaded. If your absolute value inequality has a less than symbol, then we're going to use the word and. So if it has less than or equals, we're going to use the word and, which means we're going to be looking for the intersection. So pretty much, guys and gals, we're going to put Module 6 and Module 7 together. Let's go to the whiteboard. Okay, let's start out here. This is an absolute value, but it's an equation. And we said it the last time we met that to solve this, you could technically rewrite it as two equations. Once the absolute value is isolated, absolute value is that's your distance from 0. So what you're saying is what's inside there could equal 3, or what's inside there can equal -3. Because if this is your distance from 0, here's your number line. If I move 3 to the right, I'd be at +3. If I move 3 places to the left, I'd be at -3. So because that's an equation, we have two solutions. But what happens if it's not an equation? What happens if it's an inequality? The absolute value of x is greater than 3. Well, the process is still the same. Isolate the absolute value. It's isolated. Rewrite this as not one inequality, but two. The key is going to be the connecting word. If this is a greater than, you're going to use the word or. And the way I remember that is greater than means I have more of something. And more has in it the word or. So when you have an absolute value inequality, if you have a greater than symbol, the connecting word is going to be an or. So now you're going to write me two inequalities. You're going to do exactly what you did here. If you think about the number line, absolute value is, this is your distance from 0. You are a distance that doesn't equal 3. You're a distance greater than 3. So think about if you're on the number line. If I'm here at 0 and I say move me a distance greater than 3, do you agree you can move to 4, 5, 6, 7, 8? And that would be your first statement. I can move a distance greater than the number 3. But I can also move to the left a distance greater than 3. And if I'm here at 0 and I go greater than 3 spaces, I'd be at -4, -5, -6, -7. Well, we wouldn't write x is greater than -3 because -4, -5, -6, and -7 are not greater than -3. They are less than. So what you got to understand to do is when you have an absolute value inequality, you're still going to break it up into two. Instead of two equations, it's going to be two inequalities. The first inequality, you're going to copy exactly what you see here without the bars. The second inequality, when you make that distance go in the opposite direction, instead of going 3 to the right, I'm going 3 to the left, you make that symbol go in the opposite direction. Because I'm going a distance that's less than -3, which means I'm going to -4, -5, -6. Now that's already solved. Now they're going to ask for the answers in both set builder and interval. So we got to draw the actual number line correctly. So let's think about this. If we draw this, here's 0. This says x is greater than 3. I go to 3. Greater than is to the right. There is no equals. I put a parentheses. X is less than -3. I go to -3. Less than is to the left. No equals. Put a parentheses. So that's my picture. In set builder, we talked about it. Or means unite. Take both sets. So this is your or statement, just the way it is in set builder. You just put your braces, x such that, and you write it. Okay? So an or statement should always be two inequalities connected with the word or. In interval, you're uniting what you shaded. So if you look, you shaded two different regions of the number line. So to represent this, we would say, all right, that goes from -infinity, it's starting at the left, and it goes all the way to -3. And then the other shading begins at +3 and goes all the way to the right. And then instead of using the word or, we use the symbol U for unite. So we're putting together what we learned in Module 6 now with Module 7. An absolute value inequality is still going to break into two. You're going to need a connecting word. You decide it by the symbol. Greater than is more. More means or. Or means I want, when I draw the picture, the union. Let's take this one. Absolute value x is less than or equal to 3. Okay? Step 1 is always isolate the absolute value. It's isolated. So now I'm not going to write one inequality, I'm going to write two. The first inequality is going to be what I see here. X is less than or equal to 3. I need a connecting word. If we have a less than, the word is going to be and. No thinking, memorize it. The second inequality, you're going to write x, but because you're changing that number to a -3, you have to reverse that symbol. Now that makes sense. If you think about the number line, absolute value is a distance from 0. You're saying I'm going from 0 a distance of 3, but I'm going less than 3. So if I'm at 0 and I'm going a distance less than 3, do you agree I can go to 1? I can go to 2. I can go to 3 because it says equals. And that's what this says. Go to the numbers that are less than or equal to 3. But I also can move to the left. And if I move to the left a distance that's less than 3, I can go to -1, -2, -3. Those are all distances I'm less than 3. Well, -1, -2, and -3 are not less than -3, they're greater than. So all you got to remember if you want a procedure, isolate the absolute value is always step 1. Rewrite this as two inequalities. The first inequality is exactly what you see here without the bars. The second inequality, when you make it the opposite distance, you reverse the inequality symbol. And then you should never mess up. Now, they want the answer in both set builder and interval. So we got to go draw the number line here. X is less than or equal to 3. I go to 3, put a bracket, less than is to the left. X is greater than or equal to -3. I go to -3, put a bracket, greater than is to the right. The key, again, is this word. And means I want the intersection. Where do those two shadings overlap, have numbers in common? And if you look, it's right here. So, in set builder and interval, we've already discussed this. Interval is the easier notation because all I got to do is look at the number line. Where does that overlapping, where does that intersection begin at? It begins at -3. Where does it end at? It ends at +3. Set builder is a little bit harder. You still put the braces, the x such that. Because x is sandwiched in between two numbers, you cannot write the statement in set builder with the word and. We talked about this. The letter x has physically got to go in between the two numbers. You're sandwiched between -3, +3. How do you decide the symbols? They're always going to be less thans. Look, you're taking this statement, x is less than or equal to x is less than or equal to 3, and putting it here. You're taking this statement, x is greater than or equal to -3, and putting it here. But to put this statement physically here, you have to flip-flop it around, and that's why that also would become a less than. So just remember, and means an intersection, and to write an intersection in set builder, the x should always be sandwiched between the smaller number and the bigger number. All right, now that we got the idea, let's try a couple of more. Okay, so from your notes, here we go. I have an absolute value inequality. Step 1, is the absolute value isolated? Yes, it is. So now you're going to write me two inequalities. You're going to take the first inequality exactly as you see it without the bars. I need a connecting word. That symbol is greater than. Greater than means more, so we're going to use the word or. The second inequality, you're going to copy x minus 2. But the 5 is going to be -5. You're going to go in the opposite direction. This is the distance from 0. If I go a distance of 5, I can be 5 to the right, 5 to the left. With an inequality, when you make that distance the opposite, you have to reverse that symbol. Now these are both linear inequalities. We'll solve them. X is greater than or equal to 3, or, not 3, 7. I got ahead of myself. X is less than or equal to -3. So I solve both inequalities. X is greater than or equal to 7, or x is less than or equal to -3. We said with compound inequalities, you have to draw the picture and then look for something. What does an or mean we're looking for? Or means we're looking to unite what we shaded. So we'll draw a picture. We're going to go to 7. Greater than is to the right. It has an equals. It gets a bracket. We're going to go to -3. Less than is to the left. And equals gets a bracket. So far, so good? Beautiful. Now you have to write the answers. Set builder, interval. I prefer interval because you can look at the number line. Where does the shading start at? -infinity. Where does it go to? -3. Well, -3's got a bracket on it, but infinity always gets a parentheses. But wait, there's another shading. This shading starts at 7 and goes to +infinity. You cannot write two interval notations side by side. I know the connecting word is or, but we don't use the word, we use the symbol U for uniting. Or statement means you have two sets of answers and you take both. Now, to write it in set builder, you have it up there. Set builder always goes in braces, x such that. Set builder is writing the inequality statements, and they're right here. Here's the first one, here's the second one. So you write that. An or statement for set builder should be the two statements together. Is everybody okay? I hope so. It's just a simple procedure. You found all the numbers that will make that inequality work. All right, let's try another one. All right. Let me pull this one over here. It's kind of big, so let's pull this one over here. -3, absolute value, 5x minus 2, plus 20, greater than or equal to -19. All right. So it's an absolute value because it has the bars. It's an inequality because it has a greater than symbol. Step 1, isolate the absolute value. What did I say? Very good. You can't do anything yet till the bars are isolated on the left side. So do we have some numbers we can move? Sure we can. We can move the 20 by subtracting. All right. 20's gone. -19 and -20 is -39. we still can move the negative 3. That has nothing to do with the absolute value. So we move the negative 3 by dividing. All right, that cancels. Still have the absolute value. Now, there's lots of ways to make careless errors. Here's the first one. We are dividing by a negative number. This is an inequality. So we talked about in Module 6. When you divide an inequality by a negative, you have to reverse the symbol. Have to. Right there, you have to reverse it. And negative 39 divided by negative 3 is 13. Now you have your definition. You have absolute value is, and this is your distance from 0. So guys, if I'm at 0 and I say move me a distance of 13, I could go to the right and be a positive 13. I could go to the left and be at negative 13. That's why every absolute value breaks into 2. So the first one we're going to write exactly as we say. Now I need a connecting word. This is what you got to memorize. This is a less than, so the connecting word is and. You don't go back up here to the original and decide the connecting word. The connecting word is decided right when you're about to break it up into the 2 inequalities. So right here, we're about to break it up into 2 inequalities. I can move a distance of 13. If I go 13 to the right, I'll be a positive 13. But now I can go 13 to the left. So I write what's inside the absolute value. I'm going to go to the left. That's why it becomes negative, and I got to switch it. So instead of being a less than, now it becomes a greater than or equal to. So just remember, every time you break an absolute value inequality into 2, the first one you copy as you see. The second one, you're going to make the distance the opposite. That's why you reverse the symbol. Now these are linear. We'll solve them. They're easy to solve. We'll add 2. 5x less than equal to 15. We'll divide by 5. X is less than equal to 3. And we'll add 2. 5x greater than equal to negative 11. We'll divide by 5. X is greater than equal to negative 11 fifths. But remember, that's nothing yet. We're only halfway done. Now we got to draw a number line and then write the answer in both notations. So we're going to come up here first and draw a number line. X is less than equal to 3. Well, I understand that. I can go to 3. Less than is to the left. Equals gets a bracket. Now I got to put on the number line negative 11 fifths. Well, I know what you're thinking. Well, Miss Black, there are no negative 11 fifths on the number line. Sure they are. Even though that's an improper fraction, you got to divide that in your head and get a number, a mixed number, and figure out what it's between. 5 goes into 11 twice. So this is roughly between negative 2 and negative 3. So we'd go to our number line. Here's negative 2. Here's negative 3. Negative 11 fifths is somewhere in here. Okay? And then greater than would go to the right. And it says equals, so it gets a bracket. So there's the picture drawn. So far, so good? The key is that word. And means the answer has to be the intersection. Do you guys see the intersection between the 2 colors? Sure. It's right here. So now we're going to write that intersection in both set builder and interval. And again, interval is the easiest. Where does the intersection start at? It starts at negative 11 fifths. Where does it end at? It ends at 3. Set builder. We know we put the braces. We know we put the X such that. You never, ever, ever write a set builder with the word and. And means that answers are sandwiched between 2 numbers. So when you write an and statement, you put the X and you sandwich it between the 2 numbers. The smaller number 11 fifths, the bigger number 3. To get the symbols, I'm telling you they're always going to be less thans. The reason why is, look here. You're taking that statement, X is less than or equal to negative 3, and you're putting it right there. See how they match? You're taking this statement, X is greater than or equal to negative 11 fifths, and you're putting it here. But to put it here, in your head, you have to flip it over. That's why the symbol becomes a less than also. So that's what you got to remember, the way to write the final answers. Solving alone and getting X by itself with inequalities is never done until you graph it and then write the answer. Now, unfortunately, there are exceptions to the rules. So we have two more to look at that are absolute value inequalities. They're not hard to solve. What they are is tricky. All right, let's talk about these last two today. They're both absolute value inequalities, but if you look, the number on the right side is negative. So what do we say the definition of absolute value is? Absolute value is a distance from 0. And that distance always has got to be what kind of number? Positive. Very good. So if these were equals, if these were equations, we would say there's no answer. How can your absolute value equal a negative number? But because these are not equations, they're inequalities, the answers are not that obvious. So we can still do the mathematical procedure. This is absolute value. It's isolated. I could write two inequalities. The first one I copy just as I see. This is a greater than. Greater than is more. More means I use an or. The second inequality, I write what's inside. I reverse the symbol. And I make that the opposite. Just like we've been doing. Okay, so I can always take absolute value and break it into two inequalities and solve. So if you're a procedure person, that's always the procedure. Take your absolute value, isolate it, then break it up into two inequalities and solve them. But here's the problem. This is not the answer. If you go to your number line and you draw your picture, x is greater than or equal to negative 6. Negative 6 is here. Greater than is to the right. Has an equals, we get a bracket. Then I draw. X is less than or equal to positive 6. I go to positive 6. Less than is to the left. Has an equals, I get a bracket. What most of you are going to do is you're going to solve it, you're going to graph it, and you're going to say, oh, the answer is between negative 6 and positive 6, because you're looking at the intersection. Remember, guys, it's all about the word. These last two modules are about the English, the word. What does or mean? Or means unite what you shaded. And if you look closely, when you put together what you shaded in red and what you shaded in blue, do you all agree with me you shaded the whole number line? So this answer in set, builder, and interval is not here. This answer is you unite. You shaded in the whole number line. Well, that's easy to write an interval. You started the shading at negative infinity. You ended it at positive infinity. But who remembers how to write you shaded in the whole number line in set builder? There's your braces. There's your x such that. The only way to write that you shaded in the whole number line is saying x is all real numbers. Now let me blow your mind. What happens if I told you there was a way to know that answer and not do any of this work? Would you be ready? Good. I'm going to show you. It's all about thinking. If you look at what I originally gave you, this says absolute value has got to be greater than negative 42. What do you know about absolute value? Well, you all know whatever number's inside here is always going to come out what? Positive. And do you agree a positive number is always going to be greater than a negative number? So without doing any of this work, I know no matter what number I pick for x, this is always going to be true. Now, how are you going to explain that to me if you have no work to show? Well, you'll write a sentence. You'll write, Miss Black, if I choose any number for x and do the absolute value of it, it will come out positive. And a positive, Miss Black, is always going to be greater than a negative. Therefore, any number I pick on the number line works. Therefore, the answer is all reals. Isn't that nice? All right, let's try our last one. So our last absolute value inequality, again, is here. If you're a procedure person, the procedure works. You isolate the absolute value. It's isolated. You write me two inequalities. The first one you write is what you see. So 7x is less than negative 42. That's a less than. What word do we use? Good. We use and. The second inequality, we leave what's inside the absolute value. We're now going to make that the opposite direction. We're going to make it positive 42, so we reverse the symbol. So the procedure works. You take an absolute value, you make two inequalities. You solve them. X is less than negative 6, and x is greater than 6. A lot of you will solve it. You'll go and draw your number line for me. You'll go to negative 6. And less than is to the left, and there's no equals, so we get a parentheses. You'll go to positive 6. Greater than is to the right, and you'll put a parentheses. And you'll tell me, this is the answer, and this is the answer. I'm going to mark you totally wrong, because you did not even think about the connecting word. Remember, all the work on the paper is great, but it's not until you look at the word and get me what I want did you answer the question. You knew you had to use the word and because it's a less than. And in the picture, and means I want an intersection. Well, guys, look closely. Is there an intersection between this set of numbers and this set of numbers? Do they have something in common? No, they don't. Think about it in real life. I'm asking you, tell me a number that is less than negative 6, and at the same time, it's greater than positive 6. No number exists. So what is the answer if there is no intersection? Very good, it's no solution. Now again, you want to impress me or your instructor? You didn't have to do any of that work. You could look at this and think. If you go back to the original absolute value, you know whatever you put in here for x and multiply it by 7, when you do the absolute value of it, it's going to come out what, y'all? It's going to come out positive. Can a positive number be less than a negative number? Never. And that's why this is no solution. It's a false statement. There's no way on the right side to get anything out other than a positive number. And a positive number will never be less than a negative number. So I know there's no solution. So what I love about this is, number one, we put everything together we've talked about. And number two, it makes you think a little bit. You know absolute value should equal a positive number. So if you have an absolute value and it equals a negative number, it's telling you something weird is going to happen, a special case. And you need to think about it. All right, y'all, we're done with Chapter 1. We are done with solving equations and inequalities. Hooray on that. I'll catch you now in the next chapter, Chapter 2. Have a good one.